When you think of SpaceX, what comes to mind? Probably fire, steel, right? The thunderous roar of a Falcon 9 just blasting off into the atmosphere? We see all the hardware, but behind all of that, there's this invisible force. This secret weapon that makes everything possible. I mean, we see the rockets go up, we watch the Dragon capsule dock with the ISS, but what's the machine humming in the background? The one that orchestrates every single step, from the moment a roll of metal shows up at the factory door all the way to the final countdown.
The answer? It's software, a massive, constantly evolving ecosystem of code built and maintained by SpaceX's application software team. These are the people who are building the digital factory that builds the physical rockets. And this is their story.
And trust me, that is no exaggeration. As software engineering manager Anthony Rose puts it, their work touches pretty much every single person in every process at the entire company. We're talking finance, inventory, the whole intricate dance of parts on the assembly line. Their code is basically the central nervous system of SpaceX.
But, it wasn't always this sleek, high-tech operation. In the early days, the team faced this colossal challenge that a lot of software companies know way too well. They had to tame the monolith.
So what's a monolith? Okay, think of it like a giant Jenga tower. It's one single, huge, tightly packed structure. Every single piece is connected, which means if you pull out the wrong block, if one tiny part of the code has a bug, the whole thing, it can come crashing down.
Senior manager Kyle Madonia remembers this like it was yesterday. Pushing what should have been a simple update, it was anything but. It meant you had to redeploy the entire system. A single mistake in one little module could halt everything. It could delay critical manufacturing, even launch operations. The risk was just enormous.
And this really shows the evolution. The team moved from that super risky all-in-one monolith to what's called a microservices architecture. So instead of that one giant Jenga tower, think of it now like a set of independent Lego blocks. Each little service can be updated all on its own, and hey, if one of them fails, it doesn't bring down the whole system. This shift was absolutely essential for them to get both speed and stability. But of course, just as they were getting the hang of this new approach, an even bigger challenge just appeared out of nowhere. A project so ambitious it would force a complete revolution in how they even thought about software. And that project was Starlink.
Just let that number sink in for a second. Over 6,000 satellites are in orbit right now. I mean, this isn't like building a handful of rockets a year. SpaceX suddenly needed to mass-produce satellites on a scale nobody had ever seen before.
The old software, even the new and improved version, it just wasn't built for this kind of volume. So the question became, how in the world do you build the software for a factory that builds thousands upon thousands of satellites?
Well, they built a brand new manufacturing system from the ground up, totally separate from their main rocket software. It was designed for flexibility, for scale. They used tools like messaging queues. You can think of those like little digital mail carriers, so different parts of the factory could talk to each other and work independently without ever slowing each other down.
And then there was the data. A rocket launch? Sure, it produces a ton of data, but it has a clear beginning and a clear end. A Starlink satellite? It never stops streaming. Now multiply that by thousands of satellites, and you've got this endless torrential flood of information coming at you 24/7. To handle this beast, they built yet another new system with a really powerful, modern tech stack. They use tools like Kafka to manage that real-time flow and these massive storage systems to hold it all. And the whole thing ran on a platform using tools like Docker and Kubernetes, which basically lets them easily manage and grow their computer power whenever they need to. This was a system truly built for a fire hose of data.
But here's the thing, their philosophy wasn't just collect everything. It was about being smart. The whole goal was to grab only what's absolutely essential, analyze it fast, use it to improve things, and just keep moving, all while avoiding the dreaded data swamp, where good information just goes to die.
Now look, great technology is one thing, but what really truly sets the SpaceX approach apart is their culture. It's all about radically closing the distance between the person writing the code and the problem they're trying to solve. It's about putting the code right on the factory floor.
Just like manager Steven Saponlu says, the solution wasn't just to hire more and more engineers. No, the solution was to grow smarter. And they did that by embedding their engineers directly into the heart of the whole manufacturing process.
And I mean this literally. They moved their desks right next to the Starlink assembly line.
The software engineers actually worked shifts on the line themselves, building the satellites, feeling the pain points with their own hands. This is revolutionary. It just shatters that traditional wall between coders in some office and the people doing the physical work. By experiencing the problem, they could go back to their desks, just a few feet away, and code the right solution, side by side with the very technicians who would be using it.
So you've got taming the monolith, you've got revolutionizing manufacturing for Starlink, and you've got engineers on the factory floor. It all serves a much, much bigger goal. It's all about building a future on Mars. Because of this super efficient, smart approach, this one application software team is able to support all 4 of SpaceX's primary missions. We're talking Falcon, Dragon, Starlink, and the big one, Starship. Each one has its own crazy demands, yet they're all powered by this same core group of people. And this quote from Steven Sapolou just nails it. The real magic, the coolest stuff, happens right at that intersection of bits and atoms, where code directly shapes and speeds up the process of building physical machines that can actually go to space. And this really brings us to the ultimate point here. The end product isn't just a rocket. It's the factory itself. It's the software-defined factory that can churn out rockets and spacecraft at a speed and scale that humanity has just never seen before. And that is what you need for a city on Mars. For the engineers on the team, you can just imagine what a journey it's been. As Kyle Madonia reflects, the work went from building some internal tools to powering a global internet service, with the potential to extend that connection way, way beyond our own planet. Which leaves us with this one kind of mind-blowing thought to end on. We've just seen the software that builds the rockets, but what kind of software is it going to take to orchestrate building an entire self-sustaining city on another world? Now that is the next frontier.